Hello my dear children, welcome to my channel Sudhir Sir Chemistry. But in today's video I am going to cover atomic structure completely. But this atomic structure में introduction part which one I want to give for you, and that introduction was given in even our textbook also, NCERT and all. What that is about the Dalton's atomic theory. They have discussed about Dalton's atomic theory. Means to understand this chapter completely, first of all we should know what is the Dalton's atomic theory and what is the limitation in the Dalton's atomic theory. If you'll understand the limitation in the Dalton's atomic theory, definitely then we are going to understand this atomic structure completely, what they are going to explain in this structure of the atom or atomic structure. So according to Dalton's, what is the Dalton's atomic theory? Can we say according to Dalton's means what is the atom? According to him, what is the atom? It is the smallest, we can say it is the smallest indivisible indivisible particle of matter. I hope children you know what is mean by matter. Matter means anything which occupy the space, anything which occupy the space and has a mass is called as a matter, right? And if this particular matter, if we'll divide into two part, two become four, four become eight, like that, if we'll divide, at last we are getting the smallest indivisible particle will get. That smallest indivisible particle of matter is called atom, and that to be according to whom it is according to Dalton's. So this is about the most important concept about the Dalton's atomic theory. Yeah, that part is different that atom of the same element will have the same physical and chemical property, atom of the different element will have the different physical and chemical property, that all are there. But the most core concept of the Dalton atomic theory is that according to Dalton, what is the atom? That is the smallest indivisible particle of the matter, and that will be called as the atom. Means indirectly Dalton want to say that atoms further division of the atom is not possible. So this is the core concept of the Dalton's atomic theory, right? Take a screenshot of this statement. So according to Dalton, some important postulates also there. What is the important postulate is that if I'll say I am having the atom of the same element, so atom of the same element are identical in size, identical in mass, and in other properties in all respects. So I should say the atoms of same element, atoms of the same element are identical in size. If you compare the size of that particular atom of the same element, I'll explain you consider the element of sodium. If I'll take the example of sodium, the atoms of all the sodium are same, identical in size. Even they are identical in not only size but identical in mass. Means the atom of sodium is same size, having the same masses, and all the atom of the sodium they are having the, we can say, similar properties. So and in other properties in all respects, है ना? Identical in size, identical in mass, and identical in all other properties. Identical in, but all other in properties means identical in the physical property, identical in the chemical properties, right? In all respects. In all respect means I'll explain you what does it mean. Same element means, suppose I will say I am having a element of sodium. I am having the element of sodium, and do you know how the element made up of? Element is made up of from the atoms. Means let me say it is having a one of the atom of sodium it will have, and another also it will have another atom of sodium. See this is the atom of sodium. I want to draw in this way: atom of sodium, atom of sodium. All the atoms combine together to form the elements. Now this size of this sodium atom and size of this sodium atom is same, so identical in size. But the mass of this sodium atom and mass of this sodium atom is same, identical in mass. Physical properties and chemical properties of these sodium atom and physical and chemical properties of these sodium atom is also same. That means identical in all other properties in all aspect. Is it clear, beta? Yeah, take a screenshot. Now the next point we'll discuss here. Atom of the same elements are identical in size, identical in mass, and in all of the properties and in all aspects. But one more point I will write now. If atoms of the different elements are there, see beta, the atoms of different element, the atom of different elements are same elements are identical in size means atom of different elements are differ in size, obviously beta, differ in mass, and and differ in all other properties. Beta, differ in all other properties. For example, you take the atom of sodium and take the atom of aluminum. But if we take the atom of sodium and atom of aluminum, what we will find here? The atom of the mass of the sodium atom and mass of aluminum atom never be same. They are differ in their masses. Even they are differ in their size. Even they are differ in their properties. So this is an important postulate given by Dalton's atomic theory. But the next important postulate of Dalton's atomic theory says that key atoms of the different elements they can combine in a simple ratio. So atoms of different elements can combine in simple ratio to form compounds. You can see here, brother, atoms of different element. Let me give an example, simple example. Hydrogen, atom of hydrogen, combine an atom of oxygen also you can take, beta. So atom of hydrogen and oxygen they can combine together and form the compound. Do you know what is the compound they form, beta? Water. H2 is called as a what? Water. But you know to balance it, how many atoms of hydrogens are here, beta? 2. So I should say H2. And oxygen how many, beta? 1. So it is a 1. But do you know hydrogen atom means it is, if you write here it is a molecule, but instead of writing, if I write 2 atoms of hydrogen combining with 1 atom of oxygen and they can form the compound. Same way, beta, if I say nitrogen atom is there, it is combining with the hydrogen, they form the compound. And what is the compound they form, beta? NH3. And do you know NH3 is called as a what? But NH3 is called as a ammonia. But hydrogen atom how many? 3. Atom of nitrogen is 1 combined to form the ammonia. It is a way to explain. But actual may it is not in this way. It is in this way. Hydrogen exists in the form of H2. Oxygen exists in the form of O2 and they form water molecule, beta, make it 2 mole. Hydrogen how many? 4. So make it 2 into 2 4. Oxygen see, beta, 1 into 2 2. It is balanced. Same way nitrogen. It exists in the form of N2. Hydrogen in the form of H2. So make it 2 here. 3 2s are 6. Make it 3 here. It is a balanced equation. Indirectly, just to explain these things, what he says that atom of hydrogen combining with atom of oxygen and form the compound, atom of nitrogen combined with the atom of hydrogen to form the compound as a ammonia. But atom of hydrogen never exists as a H, beta. The stable form of hydrogen is what? H2. Atom of oxygen never exists as a O, but its representation is O, but never stable form. Oxygen atom never exists as a stable form of O. It exists as a O2 form. So when they combine together, they form the compound. So these are the stable form of hydrogen, stable form of nitrogen, stable form of oxygen. They combine and they form the compound. So what the Dalton's postulate says that atoms of different elements they combine in simple ratio to form the compound. Simple ratio means it is not like that ki half hydrogen atom combining with a 2.5 oxygen atom and form the water. Never like that, beta. It is a whole number. Whole number means you can see in water may only 2 atoms of hydrogen combining with 1 atom of oxygen. In ammonia may see, beta, 1 atom of nitrogen combining with 3 atom of hydrogen. So atoms of different element combine in what? Simple ratio, and they form the compound. Write down this one also. And last important postulate we can say, beta, atoms can neither be created nor be destroyed. Atoms can neither be created nor be destroyed. Right? This is an important postulate given by whom? Dalton's, in Dalton's atomic theory. But now we'll see what is the merits of the Dalton's atomic theory. But the merits of Dalton's atomic theory is that he is able to, right? Dalton's, he is able to explain law of conservation of mass. Means we can say Dalton's theory, Dalton's theory is able to explain, is able to explain what, law of conservation of mass. But a law of conservation of mass, I hope you have studied this one in our some basic concept of chemistry. If not, you can see beta, this particular topic was already uploaded in my YouTube channel in the some basic concept of chemistry. In playlist you can find out laws of chemical combination. So he is able to explain law of conservation of mass. He is able to explain beta law of constant or definite proportion, and he is able to explain that is a law of multiple proportion means this is a merits of this of his theory. But at the same time some demerits also there. What is the demerit, beta? He failed to explain the internal structure of the atom. This is the merits. Then we'll see the demerits or drawbacks. Better to say, beta, drawbacks. So what I'll write, these are the drawbacks of Dalton's atomic theory. Acha, what is the drawback of Dalton's atomic theory? He is unable to explain or fail to explain, right, beta? These theory failed to explain what, internal structure of the atom, right? Internal structure of atom. And I said you, beta, I said you, according to Dalton, the smallest indivisible particle is called as atom. But after few years, Thomson, Rutherford, Niels Bohr are able to explain that atoms can further be divided and it is having some fundamental particle present on it. So this theory failed to explain the internal structure of atom. Again, we can say, that this theory has some limitation. What? It could not explain how atoms of different element differ from one another. It could not. It could not explain how how atoms of one element differ from, but atom of one element differ from atom of other element. Atom of one element differ from atom of other element. He is unable to explain. Means Dalton theory is unable to explain this one also. Again, third important point, but this theory, Dalton's atomic theory, also failed to explain the experiments when the glass or ebonoid rub with the silk or fur generate electricity. This theory means it failed to explain the experiments like glass. I think this thing we learn in 10th class, beta. Like glass or ebonite glass or ebonite rubbed with silk or fur, rubbed with silk or fur. But when this glass is rubbed with the silk or ebonite is rubbed with the fur, it generates electricity. Generate electricity. So, beta, it failed to explain the experiments when the glass or the ebonite they rub with the silk or fur and it generate electricity. How by rubbing the silk or the ebonite over the glass or ebonite on rubbing with the silk or fur, it will generate electricity. How it will generate electricity, that also unable to explain by Dalton. So these are the few merits are there, and these are the few demerits are there in the Dalton's atomic theory. So, but our topic is that to learn the limitations of these limitations or drawbacks of the Dalton's atomic theory. In that one, the most important is this one. Ki why means this Dalton is unable to explain the internal structure of atom. So now we are going to learn what is the internal structure of the atom and who have discovered this all the internal structure of the atom. Right? Take a screenshot.